Good morning, everyone. My name is Greg Aranda with Graybar, and I'd like to welcome everyone to Graybar's G2 Talk presentation titled LED Tube Landslide. Don't get covered up by the hype. This talk is part of our webinar series that we offer for each month for our customers. I'm excited. We have a great discussion lined up for you today, but before we get started, I'd just like to cover a few housekeeping issues. First of all, if you are one of the first 50 people online, you'll receive a coupon for a free cup of coffee that we're happy to give you for your time today. Also, if you look at the bottom of your screen, you'll see a Q&A box. Feel free to submit questions throughout the presentation, and we'll address as many questions as we can at the end of the presentation. All of our G2 talks, including this one and anyone that we've done over the past year, are all archived on Graybar.com. So you can be sure to visit Graybar.com and click on the G2 button on the center of the web page and see any replays that we've done, and you can send those to your friends. Also, we'll be sending a follow-up email with those presentation slides from today, and that's it. So we're excited to team up with GE today. As an electrical distributor, Graybar works alongside GE to provide lighting products and technical support that can help our customers enhance spaces while saving time, money, and energy. You can visit graybar.com/powersmart to learn more about our lighting solutions and other areas where we can help you save energy. I'm excited to introduce today's speaker, Mary Beth Gotti. Mary Beth has been with GE for more than 35 years. She's currently the manager of the GE Lighting Institute in Cleveland, Ohio. Over her years with GE, she's held a number of technology and marketing sales positions, including lamp development engineer and scientist for both incandescent and metal halide lamps, and senior lighting application specialist at the Institute. She has a bachelor's and master's degrees in physics and an MBA from John Carroll University in Cleveland, Ohio. Mary Beth also has an LC credential from the National Council on Qualifications for Lighting Professionals. She is active in the Illuminating Engineering Society and currently serves on the Executive Committee for the National Lighting Bureau. So without further ado, I'd like to welcome Mary Beth and turn over the presentation to her. So take it away, Mary Beth.
Well, thank you so much, and welcome everybody to this webinar. It's a pleasure to talk to you via this communication vehicle here, and I can't think of a topic that has generated more excitement than LEDs, and I've spent my whole career in lighting, and I really haven't seen a technology that has generated this kind of excitement and this kind of buzz in the industry. And we're going to really focus on LED tubes, and you know, we get thousands of people that come to the Lighting Institute in Cleveland, Ohio every year, and you know, everyone wants to know about, you know, decisions, choices. What are my options, you know, and how do I really evaluate the wide range of products out there, all of which can work in some or all applications, but you know, there's trade-offs as we go from one technology to another, and even within the same technology, there's options, and LEDs are certainly characteristic of that. And I think one of the key things to always remember is that, again, one size doesn't fit all. I mean, a lighting system must serve the application. You've got to understand the needs of people in the space, and you know, your tools of the trade. You know, we've used light sources, fluorescent tubes and ballasts. Now we have LEDs and drivers, and there's refit solutions, but all of those that can really fit the bill and can provide some great energy savings and maintenance savings. Fixtures, and again, redefining what we mean by a fixture. You know, it used to be we had an HID bulb in a fixture, a fluorescent tube in a fixture, and now there's integrated LED solutions, which often can give really the very best performance from a quality of light and a lighting economic standpoint. But clearly, especially for older fixtures, going to brand new fixtures might be a better solution than in some sort of a refit kit. And then we're in a decade of controls. And, you know, as we start looking at LED solutions, their compatibility with controls that allow us to shut things off and dim things and respond to daylight penetrating spaces, it really is becoming a key component of any really solid energy management strategy. So these are the tools. And as we think about, what's driving this lighting revolution that everyone keeps talking about, it's LEDs, which keep getting better. You look at all of the incumbent technologies. I mean, look at linear fluorescent. It's pretty flat as far as potential for further improvements in performance. And it's pretty darn good, but, there's nothing on the horizon that's all of a sudden going to magically make fluorescent, 20, 30, 40, or 50% more efficient than what they are today. And that makes a lot of sense because, fluorescent was invented, back around 1938. So it's been around a while, that's for sure. LEDs continue to improve, and every new generation of product is even more efficient, and that gives us really the potential to design better and better products. Again, whether it's new fixtures or some of the refit tubes and solutions. The other thing that's driving change is energy legislation, and you've got a lot of customers out there that are kind of at a crossroads right now. I mean, we've got, again, focusing on fluorescent, you've got these T12 fluorescent bulbs out there. How many of them are out there? There's probably over 300 million of them out there, and they can't buy them anymore. Or they've got to buy a much more expensive one, which is exempted from energy legislation. So customers that for the past 20 years haven't gone to the T8 fluorescent retrofit solution are going to have to do something right now. And again, the decision now is to stay with fluorescent and go to T8, or look at some of the newer LED types of solutions here. And also, just coming up, just to mention, it's going to be right in the middle of July of this year when some of the standard T8s are going to go away. There's tons of other T8s out there, so not to panic, but what we call the 700 series, or GE calls the SP series of F32 T8 lamps, will no longer be manufactured. But T8s have certainly come a long way as far as energy savings and also very, very long life. So technology, energy legislation really driving this lighting revolution here. So let's just look, let's look at retrofit or refit options for T12. Let's focus on that. Again, tons of T12 fixtures, four lamp T12 fluorescent fixtures used across all types of commercial and institutional types of applications. So sticking with T12, I mean, that's kind of that's the coward's way out there. You don't want to do that. I mean, that's really low performance. Going to some of the newer T8s and what we call low ballast factor ballasts, which can give you about the same amount of light as the old cool white watt misers that have been in there. Again, retrofit technologies that have been around and been refined and fine-tuned. Going to fluorescent retrofit kits, which I'm sure you're all familiar with. So these have been around, okay? So good products, good solid options for going to more efficient fluorescent technologies. But LEDs now are offering these options. LED tubes that either can run off line voltage or can run off the existing fluorescent ballast. LED tubes running off a remote driver, so you're going to kind of, take out, disconnect your fluorescent ballast in the fixture and put in an LED driver that now you can connect to your LED tubes. Retrofit kits with LEDs where, again, similar, I guess, parallel to the fluorescent retrofit kits, but now we're going to do them with LED tubes or LED arrays. And then there's new fixtures, edge lit, backlit, different designs, 2x2s, 2x4s, 1x4s. So this is kind of the plate. This is the menu, if you will, of what people can choose today. And again, we're really focusing on LFL and tubes in this discussion. So why would you pick LEDs versus fluorescent today? Actually, you look at efficiency today of LEDs, they're better than fluorescent. And that, a year ago I wouldn't have said that, but now we're seeing products that are actually more efficient than the incumbent fluorescent technology. 50,000 hours life is pretty common without interim failures. So meaning you don't expect LEDs to die. It's not like the catastrophic failures where you got a fluorescent tube, it just doesn't work. So LEDs are typically quoted in terms of how well they maintain their light over that 50,000 hours. So, and that impacts your cost of light. Cost of ownership, if you don't have to have your customers replace tubes or as you get toward rated life with non-LED technologies like fluorescent. Great optical control. You can really put light where you want it with LEDs, which can enhance efficiency. No lead, no mercury. So for customers that don't want to really think about recycling of mercury-containing products like fluorescent. They're durable. These are solid-state devices. Of course, temperature is key. Extreme compatibility with controls. Instant on, dim them. You can shut them on and off as many times as you want without impacting life. And virtually no radiated heat or ultraviolet in the beam. So a lot of great reasons why LEDs are creating the buzz that they are. And someone had a tagline once that I've stolen. We call it the digitization of lighting. So, you're kind of thinking of getting rid of all of the classic tubes that we've had in the lighting industry. LEDs are better with controls. Why? LEDs can be dimmed without losing efficiency. LFL dimming ballasts typically reduce system efficiency. LEDs, as I mentioned, can be turned on and off as much as desired without loss in life or performance. Linear fluorescents tend to lose life and they'll depreciate in performance faster if you do this frequent on-off type of switching. Why would you stick with fluorescent instead of going to LEDs? Very high efficiency. Again, LEDs are surpassing them, but they're still very high in efficiency. There's products with the right lamp ballast combinations that can get you up over 80,000 hours of life. So extended life is a big deal from a maintenance standpoint, and it's a very well-established technology, a huge installed base out there, and sometimes the lower initial cost can really result in shorter paybacks, better return on investment. Although that scenario is changing too as LEDs improve in performance and we see a moderation in prices there. Okay, so LED refit solutions. Let's get to tubes. And, there's tons of different products out there, and some historically have not been very good, and some really great products are hitting the market right now. We've come a long way from those tubes with a bunch of LEDs and dots of light showing along the length of the tube so you can actually install them, and they look, aesthetically very, very pleasing. But, UL has established 3 different categories for these LED tubes, okay, Type A, Type B, and Type C. And they differ as far as efficiency, how easy they would be to install, and also vary in safety. So Type A is where you have an LED tube with a driver inside, and you can actually work it on an existing fluorescent ballast. Type B is going to be an LED tube, but it's going to have an integrated driver, but you're going to wire it actually to the main voltage going into the fixture. So that involves handling a high voltage connected to the sockets in the fixture to run this LED tube. And then Type C is where you have an LED tube and you install a separate driver in the fixture. So you're matching up a remote box that replaces your linear fluorescent ballast, and you're going to operate it with another box or a driver that can be mated to the LED tube. Okay, so as we look at some of the pros and cons then, so here's my Type A integrated driver. You can run it on an existing linear fluorescent ballast. This is going to be really easy to install, right? I mean, you're just going to take out a fluorescent tube, you're going to put in an LED tube. You don't have to rewire the fixture. Dimming is somewhat limited. Not quite as high in system efficiency as some of the other options, but still going to be quite good. Compatibility is going to be dependent on the type of ballast in the fixture. And one of the key I don't want to say risks, but one of the key questions, what if it's kind of an old ballast you got in the fixture? Okay, so now you're investing in an LED tube. You're going to operate in a fixture where the ballast might be ready to fail. So some of the questions and concerns that the customers have brought up. So very easy to install. The quality of what's actually in that fluorescent fixture can help determine how successful long-term this solution would be. Type B, LED tube with the integrated driver, so electronics inside the tube, but it's going to be wired to the main voltage. Installation cost is going to be a bit higher. You do have to do rewiring, and if you've read any of the caution notices and instructions for this, there's a lot of warnings. Dimming capability is also somewhat limited. It's going to be more efficient than the Type A that I just talked about. Clearly, you've got an LED tube and driver, so you don't have to worry about the compatibility now with some other ballast. But the additional safety process is required due to high voltage has really generated a lot of reports around the world, as a matter of fact, as these products have been introduced on the market. And then finally, UL Type C. Okay, so now LED tube, now your driver's remote. It's going to be outside the tube, and you're going to mount it much as you would an electronic ballast. So, similar, there's some rewiring, kind of medium installation cost, just like the one I talked about. Now, very, good controllability as far as dimming. This will give you really the highest efficiency for these types of solutions, and you don't really have to worry about compatibility. You got an LED tube and a driver. You're matching them together and selling them together, so it's not like you have to worry about some third-party component that you're not sure about, okay? And you got low voltage connection to the socket, so from a safety, you're going to really minimize shock hazards here, okay? So that's Type A, B, and C. This print is a little bit small, but that's why I kind of blew it up a little bit in the previous slide. GE is going after UL Type A. That's the one with tubes going on existing fluorescent ballast, and Type C, available now, LED tubes with remote driver. Just because of the handling of high voltage to the sockets, we are not going after UL Type B. So that's where you're running the mains voltage to the fixture to an LED tube with the integrated driver here. Okay? Okay, a few more details. And again, these families are continuing to evolve and get better. Here would be a picture of a replaceable LED solution with a remote driver. There you see the driver and the tube. Driver that can run 1 or 2 lamps. Seeing even 3 and 4 lamp solutions is coming. So again, focusing on 4-foot lengths, 1 and 2 tube solutions. 1 tube, about 21 watts a tube. Okay, so a 2 lamp system would be 42 watts. 2100 to 2200 lumens per tube, so we're over 100 lumens per watt. And by the way, these tubes have the back, no light comes out the back of the lamp. One of the questions we get, do we have to worry, about, the condition of the back reflector on, or back pan of the fluorescent fixture? But the light is essentially all coming out within about 180-degree cone. So all the light is essentially coming down and out of the tube. It's not being reflected off the back surface of the fixture, okay? It looks like a fluorescent tube when it's lit. I'll show you a picture of that in a minute. Comes in popular color temperature. So all the colors you'd expect to find in fluorescent you can get with the LEDs. 50,000 hours, L70, and you're all familiar with, as we start talking about performance of the LED tubes, 50,000 hours, L70, meaning that 70% of the light is still remaining at 50,000 hours. By the way, fluorescent is actually a bit better. Normally we think of fluorescent lamps losing about 10% of their light output by end of life. DLC, that's Design Lights Consortium. If you're not Energy Star, what do you do with fixtures and kits? Well, you get certified by this Design Lights Consortium. This is a UL listed product, okay? So, which is very important and a very rigorous UL testing, meaning that, this particular combination can be fit into a wide variety of fixtures. Okay, so replaceable LED solution with remote driver. I just took a picture. This is one of our installations here at Nela Park, and again, we've come a long way with the appearance. And again, looking at products. I mean, you don't necessarily want to see rows and rows of LEDs installed. This product looks just like a fluorescent solution. Okay, this just shows a little more details. I'm not sure if that type might be a bit small, but let me just recap just some of the highlights of that. As you start thinking about replacing T12 lamps, T12 lamps with this LED retrofit, you can save. If you're really looking at replacing a 4-lamp system, you could save maybe over 60% in energy. That's assuming that you can drop light level, and in some applications, there are many spaces out there that are completely overlit. So again, looking at that chart without being able to read the numbers, the top line would show basically cumulative energy cost for T12, and then the bottom one would be the cumulative energy cost of an LED tube with the remote driver. Okay. Okay, that's Type C. Again, LEDs, tubes with remote drivers. I wanted to talk a little bit about numbers. We can kind of get misled by all of the numbers that are thrown at us regarding performance, and are these enough lumens? I said 2100, 2200 lumens out of an LED tube. Take one of the most popular T8 retrofits today, the F28 T8. If you look in the catalog, it says 2675 lumens. You put it on a normal ballast factor ballast, you're really going to get about 2300 lumens out of that lamp. Okay, so again, it's just basic calculation there. You put a fluorescent tube in a fixture, you're going to lose some light, maybe 10%. So now I'm down to about 2100 lumens. Ambient temperature effects. We know the fluorescent changes in performance. You go a bit cooler, a bit warmer, and so maybe we can assume we're going to lose maybe another 5%. So now we're down to about 1990 lumens. So really, as you start adding all of these, they're not fudge factors. They're really just performance variables. This T8 lamp, really, you're maybe getting 1,850 lumens from this lamp. So really, if you start, comparing just light output in real applications, you need about maybe 1,900 lumens or so from an LED tube to match one of the most common 4-foot fluorescent choices there. And again, we mentioned 2,100 or 2,200 lumens in the previous product. So clearly we're there from an equivalent light output standpoint, looking at tube per tube. Retrofit kits, again, with a very common type of application with fluorescent. We're seeing them with LEDs. And again, what we're doing now is really kind of controlling the whole application. You're going to put in your LED light engine, if you will, which is going to be some kind of a linear source, different from the tubes we just talked about. This is a 2x4 kit that's about 45 watts. This gives you about 4,000 lumens, so very similar to a 2-lamp system that we mentioned before. 50,000 hours life, L70, the same Design Lights Consortium or DLC certification. Again, something important to look at. I mean, don't get involved with fixtures that are not going to have this DLC listing. You really have to ensure that you're getting a product that's got some performance teeth behind it. UL listing, clearly very, very important as well. So complete LED retrofit kit where you're controlling the application. Okay, and there's just a picture again. Strictly, it's a single. You can see the single light engine. There's a double row of LEDs that help direct light out the sides of that linear piece there. And again, you're looking at close to 60% savings in energy costs compared to a 4-lamp fluorescent fixture. Not the same amount of lumens as a 4-lamp fixture, but again, often spaces are overlit, and going to this lower light level really meets the needs of the application. Again, that's number one. As you start looking at again some of the numbers, and hopefully if you could put that up to full screen, you can read those a bit better. And I think what this chart shows is how far LEDs have come. It hasn't been that long ago where the Department of Energy had a report, let's say about 2 years ago, where they said that LED tubes weren't quite ready for prime time. This shows that LED tubes clearly are. A GE LED tube with remote driver, fixture lumens per watt is about 100. A GE LED retrofit kit is going to be somewhere around 89 or 90. And how does that compare with like a linear fluorescent? The first column is the F32 T8 high lumen, so a full wattage high lumen lamp, which has a fixture lumens per watt of about 81. That's 36,000 hours life. But if I want to get up to the very highest life with what we call our Ultra Start, it's a program rapid start ballast, I can get 84,000 hours life. Again, I'm right around a fixture lumens per watt of about 79 or 80. So efficiencies are there with LED tubes. You can get long life also with fluorescent. 84,000 hours on fluorescent, though, means that there is a mortality curve. Not every single lamp makes 84,000 hours. It typically means half the lamps have failed by 84,000 hours. So something to keep in mind. We really don't expect LEDs to fail within that 50,000 hours life that's frequently claimed. Okay, just a little bit again, understanding lumens. Again, understanding the application is just so important. But if you look at fluorescent fixtures today, 2-lamp, 3-lamp, 4-lamp fixtures. Again, a wide variety of lumen ranges depending on the very specific lamp ballast combinations that are used. But over 4,000 lumens for an LED tube or an LED retrofit kit is well within range for any 2-lamp fixture. Gets close on maybe some of the lower 3-lamp fixtures, but you can see a 4-lamp fixture, you need to get up to somewhere around that if you really need that much light. But getting up more into that 7,000 lumen range at the low end, up to maybe double that. So again, understanding the application, making sure you're not just driving light levels way down below what the customer is going to need in that application. When I think about what's next, so again, more variation. I mean, normally, we think of, 2-lamp replacements for 2x4 fixtures. Again, trying to drive down energy costs, assuming that's enough light. Again, these Type C means LED tube with a remote driver. So we're installing a driver separately, disconnecting the fluorescent ballast. It's a great way to ensure compatibility. So going up to, again, higher lumens per watt, more lamps per driver. Kind of a similar parallel to what we saw years ago with electronics, with ballast for fluorescent. And then LED tubes with integrated drivers. So again, this is Type A. This is where you're going to take an LED tube and you're going to put it directly into a fluorescent fixture. Again, high lumens per watt. Our goal is to have it run on all fluorescent ballasts. Although, as you might imagine, that's the challenge is there's a ton of different ballasts out there. So making sure that you can specify and fine tune that compatibility so you don't lead anybody astray here. Again, a lot of different products out there. I mean, our products will not require what we call non-shunted sockets. So, when you think of anyone who's gone from T12 to T8 fluorescent lamps, traditionally they would go with an instant start ballast and you'd have to shunt the socket so that you're essentially putting voltage across the lamp. You don't have the two leads on each end. So some manufacturers, again, will require that you have unshunted or non-shunted sockets, if you will. Our products are going to be designed to run on all sockets. So again, make sure, there are a lot of variations on the market today. Challenge is just ensuring compatibility with all the common ballast types that are out there. And again, the key risk, what's your value proposition, if the existing ballast fails. So, understanding how old a given fixture is and, should you invest in these LED tubes with integrated drivers if you've got a ballast that's not going to make it too much longer. A little more about UL, and again, this is we've got a number of questions about this. We just had a customer group at the Institute yesterday talking about the National Electric Code 2014, and they were saying that particular code, which often, frankly, takes years to get adopted, but saying that you have to get UL certification of a given fixture when you retrofit it now with one of these, LED retrofits, if you will. So, in talking to a number of our folks in standards and technology, if you retrofit an existing fixture that's UL approved with an UL approved LED tube, the fixture should remain UL approved. And, for our retrofits or refits, whatever word you want to call them, we're really pursuing the broadest UL certification, if you will. I mean, you can take a given fixture and a given LED retrofit. That type of testing is simple. If you're only trying to get UL for one fixture retrofit combo. If you're trying to make it UL approved across a wide variety of fixtures, the testing is a lot more rigorous, and that's the type of UL that we pursue for our products. If you retrofit an existing fixture that's not UL approved with a UL approved LED tube, the fixture with the LED tubes would need to be submitted to UL if you need that. Again, all of GE's refit solutions will keep intact the fixture's UL certification because we're certifying them for that application through UL. And then there's new LED fixtures. And, honestly, the biggest bang for the buck with LEDs as far as, and the best performance, really capitalizing on the state of LED technology is using fixtures, where you often can reduce the number of fixtures, you can get the lowest watts per square foot to light and installation. And frankly, there's a lot of very cool designs in addition to the more conventional, 2x4 or 2x2 footprints. So, again, looking at fixtures that are pretty old and beat up, maybe it's time to just, get the best performance and look at some brand new LED fixtures. One thing I did want to touch on is lighting economics. And the LEDs are making us rip up the script in so many different ways. Our metrics are changing. And one of the things that can sometimes maybe not give quite the right economic picture for LEDs is talking about payback and return on investment. And it's so much a part of our vocabulary. And frankly, we've gotten kind of lazy with lighting economics, because usually we could just look at energy savings and didn't really have to worry about all the life cycle costing when we go from a very inefficient fixture to a more efficient one. As we look at fluorescent versus LED, really looking at longer-term maintenance costs. How much does it cost to replace a light bulb when it burns out? Not just the cost of the lamp, but also the labor has to be part of that equation that you take into account. So return on investment and payback. You take your initial cost logged at time t equals 0. You look at energy and maintenance or other savings calculated on a month-by-month basis, and when all your accumulated savings equal your first initial investment, that's when you get payback. And so a lot of the internal metrics for your customers, 1.5, 2-year payback or less. With life cycle costing, you're really looking at all your costs amortized over life. The fixture cost, lamp cost, ballast cost. And then for calculating maintenance savings, you look at long-term averages for lamp and ballast failures per year. You include air conditioning, HVAC savings. For every watt you take out of your lighting, take 1/3 of a watt out of air conditioning load. So every item is reduced to this annualized cost. So it really provides a longer-term look at what the cost or value of a system is. And here's an example. You have an existing T12 a T12 system there. So the yellow is energy, the red is lamps, the blue is ballast costs. So, you have a certain amount of energy cost per year. You've got some lamp replacement costs and also ballast that will fail, again, depending on the age of your system there. You look at a new T8 system where you essentially, aren't going to have any, you don't expect any early failures within that first couple of years. And, of course, looking at LED types of solutions. So that'd be a kind of a common retrofit analysis there. Here's another one. Some of my printing got moved up just a bit here. Here's for a new fixture, for example, where the initial cost of a fixture may be quite a bit more, but you start looking at fluorescent versus LED now, where you're not expecting to have any of that red section there, which is lamp replacement cost, or the ballast replacement cost. So all of a sudden your annualized operating cost of fluorescent versus LED really shines. It really showcases the advantage of LED. So some of the things that we do here at the Institute is we look at different lighting economic analysis, if you will. So what are the best targets for LED upgrades? Clearly looking at all the T12 lamps that are out there, looking at spaces that are overlit, where going to a more efficient and lower light level option is going to really reap some high benefits. Where are energy costs really high? And, we're seeing, we talk about annual national rates of around 11 cents, but we know that there's areas where it's 13 cents, 20 cents, even over 30 cents a kilowatt hour in places like Hawaii. Concerns about maintenance. Really hard to access fixtures where just, creating scaffolding or renting a lift or anything that's going to really make it tough to replace the individual lamps as they fail. A great opportunity to use the LEDs. A lot of dimming. When it comes to dimming compatibility, LEDs really kind of reign supreme here. I mean, they love to be controlled. So daylight harvesting, occupancy or vacancy sensors, extensive use of dimming are just prime reasons to look at LED solutions. And you know what? There's customers who just want LEDs, and I know you've talked to them and run into them. LEDs have this coolness factor, and people are just enamored with them, and they really want. They almost have to be talked out of going to LEDs. Clearly we don't want to talk them out of that. We want to offer them the products that are best for them. For older, worn-out fixtures, I'd really consider new LED fixtures. It's going to give the best performance, best quality of light for a given application. Really take advantage of LED technologies today. So there are a lot of opportunities for you. I said over 300 million T12 lamps still being used in the U.S. today. Some numbers are even higher than that. That's kind of like one per person, Just amazing considering how long they've been around and how long T8 retrofits have been around. Magnetic ballasts for T12 were legislated a number of years ago, although there are T12 electronic ballasts are available. T12 lamps have basically been legislated out now, so there's some exemptions, but they're going to continue to be more expensive, and it really is a low performance lamp. I mean, any customer who's got T12 lamps, they're throwing 50% of the energy right out the window. So the cost of waiting is a key calculation there. High color rendering and specialty T12 lamps like shatterproof type products are available and still legal. The simplest solution for that T12 is replace it with another fluorescent lamp, an F28 on a low ballast factor ballast. Using to get the very longest life, go into program rapid start, which is kind of becoming the new standard. The very longest life for these T8 solutions will be on these high-tech rapid start ballasts, if you will. And LED solutions have come a long way. Again, it's in the past year, we're seeing efficiencies that are better than fluorescent, quality of light that really makes them suitable for a wide range of applications. But I would be cautious, both from a performance standpoint. I mean, what do they look like? Is the customer going to be happy with that, or is it just LED dots in the ceiling? And from a safety standpoint, it's kind of the wild, wild west out there with some of these refit tubes. So looking for, is it UL type A, type B, type C? What are the what are the caution notices and installation? I'll tell you one story. We had a customer call us, and they had one of these LED tubes that was meant to be operated on mains voltage to the socket. What was happening that as they're installing the system, the workers were getting shocked. And so the answer was, well, maybe you ought to ground that tube each tube to the fixture. So these are the types of misses that can happen when you have products that maybe aren't designed as well as they should be. So again, ask questions. Know the product differentiators. What really is going to give you the best guarantee that you're going to have an installation that's not only safe to install, but it's really going to generate the customer satisfaction. That's all I have right now in my prepared presentation. So at this time, do we have any questions in the chat box?
Hey, Mary Beth. Yeah, we sure do. Thanks for that. That was a great presentation. Just a reminder to everyone, you can still submit questions in the Q&A box at the bottom. And we've got plenty here lined up. So, Mary Beth, if you're ready, I'll just read through them.
Okay.
Joanne's asking, if we're developing an energy program, is it advisable to follow Title 24 if you're in Colorado or a state that legislates under a different program?
Well, Title 24 has been always the leader and shaker in the industry as far as energy codes is concerned. And it's safe to say when it starts in California in Title 24, it tends to move, across the country. So Colorado certainly is a very green state. So I would say that, following Title 24 would put them right on the leading edge with California. I would think that would be a great recommendation.
Okay, great. If you're using an LED tube where the LED is contained or housed inside a glass tube, how is the heat escaping?
Well, the distribution of the LEDs is very important. So, you've got a certain number of watts, and as you increase the surface area, then the dissipation of heat is simpler. if you've got a very compact lamp, let's look at some of these LED screw-in retrofit lamps. I'm limited. I'm trying to keep something small, like an A19 incandescent. I can only put so many watts in that and dissipate the heat. So, as you start getting to long runs of linear LEDs, then dissipation of heat through that large surface area becomes easier.
Okay. Bonnie is asking, what happens when you have an older LFL ballast with a UL type A?
Well, that's one of the catch-22s there. As you start thinking, essentially if the ballast fails, you've got a product that doesn't work now. So now you've got a fairly expensive LED tube, which is it's going to be a lot more expensive than a fluorescent tube. So now you have a choice. Now you either replace the ballast, fluorescent ballast, or you have to, or just refit it with an entirely different solution. You could take out the ballast and go with a remote driver and a different LED tube that requires a remote driver. That's the risk. That's your value proposition starts to fall apart if you're going to buy, fairly expensive LED tubes and your fluorescent ballast fails. So the most straightforward thing would just be replace the fluorescent ballast.
Okay. What about battery backup ballast compatibilities with LED tubes?
That's a great question. I know that's something that's on the product development path. I'm not sure. We'll have to get back to you on that one to see what the status of that is. I honestly don't know.
Okay.
Emergency backup, you mean?
Sure. Sure.
Yeah. I'll have to check on that and see. I don't think that's available in our products right now, but we'll get a definite answer on that one.
Okay, we'll definitely follow up with Stuart on that one. When GE introduces the Type A product, will they publish a list of compatible ballasts?
It depends on how, if we can design something where it looks like it can be pretty much one size fits all. Hopefully that wouldn't be necessary. Wouldn't that be a great thing? If you could all of a sudden say, any of these rapid start, instant start program, rapid start ballasts, and it's going to work fine. So if it looks like there's a significant, a substantial enough number where we know there's going to be issues, then we certainly have to publish that.
Okay. Kathleen is asking, when will integral LED tubes be available?
From GE, it looks like early August.
Okay, great. James is asking, with the rapid changes in technology, what are the chances of not being able to get drivers or lamps that are compatible with those I already have installed?
I would say, honestly, that's part of our responsibility as manufacturers. Clearly you've got, you have a loyalty to people who have, you have to use products for a certain number of years. So, when you start thinking of 5 years, 10 years, making sure you can support that product. So, in general, looking at, seeing things that are obsolete a driver, I don't really see that happening near term. Usually the advances, let me back up, the advances that happen in LEDs get more efficient. We can improve the electronics, but, really changing the technologies to such a point that we won't support something that exists, I think that'd be a pretty remote possibility.
Okay. Do you anticipate the 50K rated life will increase? Still seems a bit low for the LL lamps, or compared to LL lamps. Life of LEDs is, as an industry, we're looking at life not based on failure as all the other non-LED technologies. So, and one analogy, you think of, a flat tire versus measuring tire treads. Okay, so 50,000 hours really reflects a lumen maintenance value, if you will. So L70 at 50,000 hours, L85 at 50,000 hours, where we've only lost 15% of the light output. The weakest link in these systems is going to be the driver. So, as you get to more robust electronics, you're always trying to compromise components, reliability. But the fact is, electronics have failure points. If we put electronics in that would increase cost by a factor of 10,
to get longer life. That would not be a reasonable solution. So, life ratings may, we tend to be very conservative, very honestly, but 50,000 hours, again, not based on catastrophic failure. It's a lumen maintenance rating almost, okay?
Yeah, there's another question along the same lines. Jeff was asking, is there a rating on the life of the drivers?
We expect the life of a driver to be similar to the life of an electronic ballast. So, you look at warranties, typically a warranty will be 5 years. You expect it to last a lot longer than 5 years, just like warranties on your car, warranties on your appliances. But so I'd say similar to fluorescent electronic ballast.
Okay, very good. Okay. Another question here: will the Type A and Type C options be Energy Star or DLC listed?
DLC. They are DLC. They are or will be DLC listed. Yes.
What Kelvin temperature appears to be growing in popularity? I hear 50K, 65K. Is that true?
Based on our data, we'd say 4,000K is still by far the most popular color. Manufacturing, some educational facilities, 50K. Personal preference counts. 40K, 4,000 kelvins, tends to be not too warm, not too cool, tends to fit a wide variety of tastes. 5,000K better for daylight harvesting, blends a bit better with daylight without being too harsh. 65K in this country tends to, for electric lighting, is often perceived as being a little too cold. So I'd say 40K is still would be my recommendation for a safe choice.
Okay. I've got a question here from David. What are the Type C LED performance limitations at temperatures between 0 and negative 20 degrees Fahrenheit and above 90 degrees Fahrenheit?
Cold is absolutely no problem. What was the upper limit that you had mentioned?
Above 90.
Above 90 F. Yeah, electronics
Fahrenheit.
Yeah, electronics tends to start to hiccup as you start getting over 130 F. That's ambient in the vicinity of the luminaire. The drivers that are actually used, and I would have to check the temperature ratings on that. I want to verify that because I want to make sure I give the right answer. I would say 90 F should not be a problem.
Okay, great. We're running out of time. I'm going to take one more question here. Stuart's asking, do you see application for retrofitting Generation 1 T8 systems?
So people that have gone to the standard F32 T8 and now they're looking for a retrofit, so they've already gone from T12 to T8. Is that
right?
Yeah.
I think so.
Yeah, right now, again, the options are really similar to what you would do with replacing T12s. They're far better T8 solutions. We said that some of the standard F32 T8 700 series, or SP series in GE jargon, will stop being made in a couple weeks here. Again, you could still stay with F32 T8, but you could save about 14 watts in a 4-lamp fixture by going to an F28 T8. So you can upgrade to a more efficient T8, or you consider going to LED tubes in that application. So you can stay with fluorescent, or you can go to LEDs. Just same type of decision if you still had T12s.
Okay, well, we are out of time, Mary Beth. I really appreciate you joining us today, and I thank everyone else out there for their questions. We will surely follow up with you with answers to those questions. I just want to remind you that this presentation is archived on grayware.com under the G2 Talk section, and also we'll be sending you the PowerPoint slides probably tomorrow. So, again, thank you for your time, and I hope that you'll join us next month on July 24th, where we'll be addressing lighting in healthcare facilities. So thanks a lot. We will see you next time.
Yeah, thanks for all the questions, everybody. Have a good day.